Okay, let's see if we can factor these ones and use the factored form to sketch them. Okay, a couple of reasons why this might be nice to use the factored way. Can you see that if you tried to complete the square with both of these, that you would end up with fractions? Can you see that? Because you'd factor out the 2, and then this term would be 5. And then you always have to divide by 2 and square. That'll be 5 divided by 2 and squared. You'd have fractions.
Sorry for the interruption, but attention all staff and students. Anybody in your period 3 classes, if you have any donations for the...
Is Mr. Johnson the cell phone there? I don't know.
Factor out the negative 2. Leaves you with x squared minus 5x plus 7. Notice in the factored form, you take the minus 2 out of all of them. Whereas when we were completing the square, you just take the a value out of the first 2. Like completing the square, you would still have the x squared minus 5x. Then we'd put the space. And with the 5 here, we would have a fraction when we were completing the square, which isn't terrible, but doesn't make it easy to find, as easy as without fractions. Oh. Can we factor that? No. Can't be factored. What's that? Why can't it be factored? Well, I'm looking if it could be factored. So this is what I did in my head. I said if it could be factored, it would have to be x and x. And the only way to get 7 is 7 and 1. And until I made a mental math mistake, I never got 5. But if you make a mental math, 7 minus 1 is 5, then it works. But mostly it doesn't work. So it can't be factored. So now if I wanted to sketch this graph, now I would have to go to a completing the square technique, because that would be the only way that you could do this one. Unless, of course, it could be factored. No, it can't be factored. So let's go. Let's complete the square just for good old times. Completing the square, you would leave the minus 14 on the outside. So this is good review anyways. Leave a space, leave a space. So it's going to be good practice with fractions anyways. What happens when I divide negative 5 by 2? I get negative 5 over 2. And when I square that, I would add 25 over 4 into that space. What have I actually done? I have actually subtracted 25 over 2. So the opposite of subtracting 25 over 2? Adding 25 over 2. And so now I would get y equals negative 2 x minus 5 over 2 squared. And in order to put these fractions together, I need a common denominator. Negative 14 is negative 28 over 2 plus 25 over 2 would be plus 3 over 2. What's that? Because if I take this negative 2, the a value, and one of the steps that when we wrote out our steps, which you have on that previous page or a couple, we said always remember to multiply by a, because when I put 25 over 4 in the brackets, it also gets multiplied by this negative 2. And when I do negative 2 times 25 over 4, make this a fraction, negative 2 over 1, you'd multiply, you'd get negative 50 over 4. That can be reduced to negative 25 over 2. And then if you've subtracted negative 25 over 2, you have to do the opposite here so that it ends up doing nothing. And so our vertex is? What would our vertex be? Yes, thank you. Thank you very much. Because I'd have negative 28 over 2 plus 25 over 2 minus 3 over 2. Our vertex will be positive 5 over 2, comma, negative 3 over 2. So when we go to graph this one, so when we go to graph this, 5 over 2 is 2.5. Negative 3 over 2 is 1.5, negative 1.5. So our vertex would be 2.5, comma, negative 1.5 would be right there. Is our graph going up or down? Going down. You would label your point 5 over 2, comma, negative 3 over 2 on your graph. It's going down because the a value is negative. You would go over 1, down 2 to find your next point. If I went over 1 to the right, I'm at 2.5. Can you see that that would be now at 3.5? Agreed? Going over 1 to the right? Going down 2, I was at negative 1.5. If I went down 2, I'd be at negative 3.5. Our axis of symmetry is at x equals 5 over 2. Again, put arrowheads on your graph, and we use completing the square to graph it, because we couldn't factor it, even though we tried. Part B, yeah, I'm recording this. Part B, let's see if we can factor this one. Again, if I'm trying to factor something, especially with an a value of 4, there is no common factor, so I'd go right to my brackets right away. I don't know if it's 4x and x or 2x and x. I can't tell that by looking at it. But for 5, I do know that the only possibility is 5 and 1. So I'll start with the 5. Is it going to be 2 and 2 or 4 and 1? 2 and 2. Because can you see that the inside makes 10, my outside makes 2, and that makes 12. And they'll both be positive. So if you made y equal to 0, if you make y equal to 0, you get both of your x-intercepts. So now when we go to graph, we know that negative 1/2 and negative 2.5 are our two x-intercepts. Where's our axis of symmetry going to be? Between them. So if you add them up, if we take negative 5 over 2 and add negative 1 over 2, then divide it by 2, you get negative 3 over 2 as the middle. And maybe you could just even see that negative 1.5 is right in between them. Plugging that value in, and again, I'm going to go to my calculator here. Four times negative 1.5 squared plus 12 times negative 1.5 plus 5 So what I did is I know my axis of symmetry is negative 3/2. I went back to my original equation. Is it plus 12? Yeah. And substituted in negative 1.5. And I got an answer of negative 4. So negative 1.5 comma 4 is my vertex. Label all of our points. Put arrowheads on the end of our graph. And we're able to draw this parabola using the factored form. So the first one, you couldn't factor it. So then you had to use the completing the square. This one you could factor. Some people may still argue, even after factoring, that it would be nicer to still complete the square to graph. Some of you might still find out, I like to complete the square because that gives me my vertex right away, and that helps me find everything that I need. If I wanted to find my y-intercept of this graph, can you see that it's going to hit when x is 0? Can you see that y would be 12? If you plugged in 0 for x, no, sorry, y would be 5. You plug in 0 for x, you would get a y-intercept of 5. So that's another point you could label on your graph. Questions for this one are 6 and 7.